Hello and welcome to a proof of circle theorem 6, that's the intersecting chords theorem in the case where the chords cross inside the circle. The proof, we want to prove that circle to crossing point times circle to crossing point is circle to crossing point times circle to crossing point, or ax bx equals cx dx. The first step, what I'm going to do is I'm going to draw in a couple more chords. I'm going to join A to D and B to C, whoa, like that. And I'm going to claim that these two triangles, AXD and CXB, are similar, and I'm going to do that by proving all their angles are equal. So I'm going to refer to the angles in this sort of frightening way. I'm going to write DAX, that's this angle up here, equals BCX, I guess. And the reason for that, those two angles being equal, is they're angles in the same arc. They both shine onto the arc DB. Angles in the same arc. Angles in same arc. It's always important to give your reasons when you write these things down. And I'm going to write that this angle at the bottom, which I'll do with 3 marks, that's the angle ADX. Okay, so notice the order that I write these things in is obviously crucially important. ADX is a totally different angle to DAX, on the bottom. But it's equal to CBX. That's actually the same reason. I'm going to put little ditto marks. Angles in the same arc, but the arc is different. It's the arc AC that this angle at the bottom shines onto, and this angle here shines onto as well. That's actually enough to show two triangles are similar, because you only need to check two angles. The last angles will be equal by angles in a triangle adding up to 180, or using vertically opposite angles. So, let's get it down. The triangle AXD, I might even put triangle in front there just to make it clear that it's not an angle. So triangle AXD is similar to, you could write that in words, or you could use that little tilde, CXB, triangle CXB. Okay, so they're similar, and now the rest is actually quite easy. I'll head over here. Once they're similar, I can take an internal ratio and say AX over DX is equal to the same internal ratio CX over BX. And then it's just a case of multiplying up both sides up by the length BX and the length DX, so cross-multiplying, I suppose. AX times BX equals CX times DX. And we're done, actually. That's the end of the proof. I'll just comment that you could, if you had wished, taken an external ratio and said AX over CX is equal to DX over BX because of the similar triangles, and when you multiplied up, you would have got the same result.